Hi everyone, hope you are doing good. So, today I'm going to start the section 9.4, which is the hypothesis testing. How we use this kind of hypothesis testing, what we have learned so far. Actually, we learned from chapter 9, section 9.1, 9.2, and 9.3. What are the components we need to perform this hypothesis testing? We learn p-value and critical value. So in this section 9.4, I think this is the most important section in chapter 9. So we are now going to apply whatever we've learned so far into this hypothesis testing. So as always, sigma is known. We are considering population mean. So hypothesis testing for one population mean with sigma known. Okay, uh, let's consider our C test, our traditional C test. If we have our population like this, known mu sigma, then we can say that our sample or samples x bar has a normal distribution with mean mu and sigma over square root of n. Okay, when sigma is known, that's really important. Or when n is greater than 30. Why n is greater than 30? If our population is not normal, still we can have our still we can assume that our sample has a normal distribution if we have sample greater than or equal 30. Okay, that's what this says. So then we can do a hypothesis on population mean. We are doing our hypothesis based on population mean. Okay, mu equals mu naught, something like that. So sample should be a simple random sample. These are the basics, you know these things. If we need to perform, before we need to uh, do this hypothesis test, we should make sure that we have fulfill these conditions. So we have simple random sample, and we have null hypothesis for the hypothesis testing. Yes, it's true. It's here, it is a h naught, mu equals mu naught, some kind of value. Then we need to calculate our test statistic C. How we calculate that? C equal x bar. This is our mean. Um, this is our sample mean minus mu naught. What is this mu naught? The mu naught they have given. See, mu naught they have given. Divide by sigma over square root of n. So we calculate our test statistic C equals x bar minus mu naught divided by sigma over square root of n. Uh, this is the variance. Oh, let's say this is the standard deviation from my x bar distribution. Okay. Uh, when to use this one mean C test? Okay, this is really important. We cannot apply this C test whenever we have hypothesis testing. There are some restrictions. So you should uh, first place you should know these conditions are satisfied before you use this C test. So when sample size is small, okay, then still you can use C test. The variable which mean your population is normal, which mean normal distributed with known variance sigma. You know, if you know your population is normal distributed with known standard deviation. Oh, sorry, this is not variance. This should be your standard deviation. Standard deviation, STD, sigma. Okay, okay. if already you know your standard deviation, this is not variance, this is again standard deviation, I'm sorry, still you know your standard deviation, and you know that your sample size is large or large enough, which means greater than 30, then you can use this C test. Okay, if you let's say fulfill these two conditions without having any outliers, you can use the C test. So actually you don't need to consider outliers in this section, because in your course for this section there are no outliers. So in general, if there are no any outliers in your data set, and also they satisfy this condition, then you can use one mean C test. Okay, uh, let's see how we do this hypothesis test. Population mean mu and sigma is a standard deviation known. So I have summarized here what we have discussed so far. Actually, first state the null hypothesis and alternative hypothesis. This alternative hypothesis mean always your claim. Okay, so null hypothesis always h naught, we denote by h naught something like mu equals mu naught. Okay, so in your case your null hypothesis always mu equals mu naught. Okay, so always mu equals mu naught. In any case, you see in this course maybe two tail, left tail or right tail, only from these three. Okay, so next you need to mention the alternative hypothesis HA. So this alternative hypothesis based on your claim. So according to this claim HA, you have to decide your side of this distribution, which means two tail, left tail or right tail. If it is, for an example, if it is greater than your alternative hypothesis, it says that mu greater than mu naught, which means it is under right tail test. Okay, so already we have discussed these things. Second one is find the significant level. So you have to figure it out what is your alpha in your problem. If they haven't mentioned your alpha, what you have to do, you can take alpha equals 0.05. Okay, that's a default value. Then you have to calculate your test statistic. See how you calculate it. Sample mean minus given mean mu naught divide by sigma over square root of n. Then you can get that calculated C value. Let's denote by C naught. After that, you have to decide which technique you are using to perform this hypothesis testing. Already you know critical value approach and p-value approach to perform this hypothesis testing. So in this section, section 9.4, we are talking about both approaches. Okay, but in general in your question you have to use either one, either critical value approach or p-value approach. If they haven't mentioned in the question specifically, okay, you have to use p-value approach or you have to use critical value approach, then you are free to use either one of these. Okay, then finally don't forget you have to interpret the results. Okay, let's go through a few examples. First example, they have given a data set something like this, and they will give all the necessary information. So when you are reading this question, you have to track down what are the necessary information. See this, at the 1% significant level they have given alpha. Okay, so what they need to find, mean height of today's women in their 20s is greater than the mean height of women in 20s. Okay, this is the keyword. See, they need to find something greater than. So this gonna be your keyword. Using this, you should be able to figure it out. Okay, which tail test do I need to use? Since this is greater than, if you remember, I have mentioned how we select the tail using the keyword. If it is greater than mean, so I'll write it on the top. Greater than mean, you have to use what? Right tail. Okay, so you have to use right tail. So see, I have mentioned here keyword to identify alternative hypothesis. So this greater than keyword goes to your alternative hypothesis. Okay. Okay, so they have given it was 62.2. So this is your mu naught. So they have given mu naught. Okay. Okay, you know alpha, you know what is the alternative hypothesis. Let's do this. Uh, Here we have given the sample data. So they haven't made, but already they haven't mentioned what is the sample mean. So you have to do it by yourself. All the summation of all the uh, data they have given to you, divide by number of data you have. So you can calculate sample mean. It is 64.24. So step number one, mention the alternative hypothesis and null hypothesis. So null hypothesis always mu equals to mu naught. You know here mu naught is what? 62.2. Then your claim HA or alternative hypothesis mu greater than this value, mean value. Okay, greater than that keyword. So you know this is a right tail test. This is a right tail test. This is a right tail test. Okay. Uh, Step number two, identify the significant level. Significant level, they have given you 1%. 1% mean 1 over 100, which mean 0.01. We always use these decimal values, not percentage. Okay, so 1% means 0.01. Now you have to calculate your test statistic C, or let's say C naught. How you calculate? You already know what is X bar, number of observations you have. What is the standard deviation they have given here? See, I forgot to tell you. uh, where is that? The woman in their 20s. Okay, standard deviation of the height of today women in their 20s is 2.88. So you know that value. Clear? Now you have to apply, now you have to plug all the values into this formula and get what is this test statistic value. It is 2.85. Okay. Okay, step number four. You know what is alpha? Now you have to decide uh, what we need to do. Okay. After this step, actually, as you mentioned, we have two approaches: critical value approach or p-value approach. After this point, you can decide which method you are going to use, or you can decide it's in the first place. So as I mentioned here, we have used critical value approach, which means I'm going to use critical value approach to solve this problem. Okay. Okay. uh, Here, so since this is a right tail test, this is your claim. So in critical value case, what you need to do, after you figure it out your alpha value, you have to find what is the C value based on this alpha value. So critical value goes to 2.33 based on this value. Do you remember that? How we figure it out those values? Okay. Using C table, find the particular Z value for this alpha. So that value is 2.33. This is this 2.33 value. Okay. Okay. Uh, Next, you know what is your calculated value, 2.85. So it is somewhere here. See, your C value based on your your alpha value, it is here, and your calculated value somewhere here. So now what? Your calculated value is inside the reject region. So 2.85 is in the rejection region as in the figure. Yes. Which means test statistic value, your calculated value is greater than your critical value. Okay. So what we have to do? Reject H naught. Last step, interpretation. Since your test statistic value is greater than your critical value, you can say, okay, therefore, at 1% level of significant, or you can say 0.01 level of significant, we reject our S naught, or we reject our null hypothesis. Then you have to say we have enough evidence to say that mean height of today's women in their age 20s is greater than 62.6. You can stand with alternative hypothesis because you have already rejected your null hypothesis. Okay, so please check how you interpret at the end. Okay, what we have used, we use critical value approach. Next I'm going to use p-value approach to the same question. As I mentioned before, you know what is x bar, right? You know what is the mean, and most of the steps are similar. So first step, denote your mention your H naught and HA, then your significant level, it is 0.01. Remember that we are using p-value approach. Okay, same as before, calculate at your C naught value, which means test statistic value. Okay, then find the p-value based on your test statistic value. You know how to do this. Because you learned this in chapter 9.3. Okay, how to use p-value. So calculate the p-value based on C naught equal 2.85. So that value is somewhere here. So this is a right tail test. Still this is a right tail test. Okay, it doesn't matter whether you use critical value or p-value. This test is right tail. So your p-value is 0.0022. Your p-value is 0.0022. So what is your alpha? Sorry, 0.05. So you have to compare your alpha with this value. Okay, hold on. Why this p-value 1 minus? Because this is right tail test. You have to get 1 minus your table value. Okay, please check chapter 9.3. Okay, so compare these two values and you will see your alpha. What happened? Your alpha, oh sorry, it's not 0.05, I'm sorry, it is 0.01. Okay, your case. So p value greater than or less than, p value less than your alpha. Since your p value less than our alpha value, what you have to do? You have to reject null hypothesis. Okay, then you have to say same conclusion. Consider this note, so I'll use another color. Okay, you can use either p-value approach or critical value approach, but please do not use both, just one method. Okay, it doesn't matter which method you use, at the end you have same answer. Okay, okay, um Let's see another example. This example based on two-tail test. How you say this is two-tail test? Okay, go through this example, read this. They have mentioned some important values, so I just only focus on most important points in this problem. Okay, so how you going to understand, or how you going to make sure this is two tail or any other right tail or left tail? Go through this question and identify what they need to find. Differs from the national mean in Australia. Differs is not less than or greater than case. Differs, the difference. So this is the keyword which goes to alternative hypothesis, which means this is a two-tail test. They have given their alpha. Okay, always significant level mean alpha. And mu naught, where is the mu naught? Australian is 16.7. This is your mu naught. Okay. Okay. When you read the question, I identify what are the most important facts. Okay. Uh, what is mu naught? Yeah, mu naught is 16.7, and mean length. There is no data set, so they have given you a mean length, which mean your x bar. Okay. Okay. So x bar they have given. You don't need to calculate it. First step, the mention what is H naught and HA, alternative hypothesis. Alternative hypothesis says that differs, which mean not equal. So your alternative hypothesis is mu not equals 16.7. So as always, H naught is mu equals mu naught or that value. Okay, you know what is your significant level alpha? It is 0.05%. Okay, compute the test statistic. As always, they have given all the necessary information, right? I didn't read the question, so yes, x bar given and number of observations 100, sigma given, standard deviation given. So plug all these values into this formula and calculate your C naught. Okay, now which method you are going to use? Okay, I'm using critical value approach first. Next we will use p value approach. Okay, first critical value approach. You have your C value 1.83. Okay, you have to since this is two tail test, you have to find the C score value for alpha value. Okay, so you know how to do that. So go back. If you don't remember, go back to chapter 9.2 and figure it out how we find this. Since this is two tail test, you have to get the half of this alpha and find, okay, if you get alpha over 2, which means 0.025, then go to the C table and find these values. You will get two values. Why two values? Because this is two tail test. Okay, one is negative, the other value is positive. Same value but different signs. Okay. Okay, we denote in negative C alpha over 2 and positive C alpha over 2. Anyway, you can figure it out what is those alpha values. Okay, then what is your calculated value? I think 1.83. Oh, I'm sorry, it is 1.83, right? Okay, so you have negative 1.96. I'll draw here your negative 1.96 and your positive 1.96. These are the as negative C alpha over 2 and positive C alpha over 2. So where is your 1.83? It is somewhere here, right? So these regions are rejection regions, right? Whatever inside this region we consider as reject region, rejection region. But this value, where is that value? Somewhere here. It is in the not rejection region, right? So your test statistic is non-rejection region outside the colored region. So we do not reject our null hypothesis, which means you can simply say your test statistic value is less than your critical value. So 5% significant level, we do not reject null hypothesis. Which means we do not have enough evidence to say that your alternative hypothesis. What is that? Length of imprisonment for motor vehicle theft offenders in Australia. Okay, clear? So main thing in this interpretation is what happened actually, then in what alpha level you are considering here, then you have to say, okay, if it is not do not reject, then you have to say we do not reject because what, we do not have enough evidence. Okay, we do not have enough evidence to say what, say your alternative hypothesis. These two lines your alternative hypothesis. Okay, that's how we build the interpretation. You don't need to add any stories, just one two lines, that's fine, but you have to clearly mention all the necessary information here in this piece for the interpretation. Okay, okay, let's see how we solve this by using p-value approach. Okay, x bar given, first step, you need to mention what is your h naught and what is your alternative hypothesis. Okay, step number 2, what is your alpha? Step number 3, as usual, calculate your c naught. Since you are using p-value, you have this alpha, and what you have to do, you have to find the probability value based on this c value. Okay, so this is two-tail test. You will be having two areas like this. So what is this value? uh, what is the p-value based on I don't remember the value. It is sorry, it is 1.83. So based on 1.83, convert this into a p-value and it gonna be 0.0672 positive. Okay, please check chapter 9.3 how we calculate p-value for the two-tail case. 2 times, since it is two-tail, 2 times your delta naught. Do you remember that delta naught value? Okay, this is the delta naught value, calculated value from the standard uh, normal table. Okay, so this value 0.0672. So you have to check whether it is greater than or less than your alpha 0.05. This is 0.06, which means definitely your alpha is alpha is greater than, right? See, this is your addition. This calculated value greater than not alpha, this is 0.06, so your calculated value is greater than your alpha value. Okay, your calculated value greater than your alpha value. So p value greater than significant level, what you have to do not reject. Okay, it is outside the region, do not reject. So interpretation same as before, since we are using the same question. Okay, let's see the last example, left tail test. So already we have done right tail test and two tail test. So this is the left tail test. How we identify this as a left tail test? Read the question and focus on what they ask from you. Less than this value. So in the question, I'm going to focus on what are the main points. So I'm not going to read the question. Okay. So how we identify what kind of test is this? Go through the question and find what they have mentioned you to find. Okay. You need to find uh, sufficient evidence to conclude that the mean daily uh, charge for hotel and motels operating in South Carolina is less than $75. So less than mean left tail. Do you remember that? Less than left tail. So they have given, there is no data set, so they have given sample size and their mean daily charges. They have given the mean of the data set. They have given your alpha, and also they have given standard deviation. Okay. Okay, they have given their mean. You know what is n, right? So step number one, mention the hypothesis. We are using critical value approach. First critical value approach, next p value. Okay, h naught mu equals 75. Alternative hypothesis, they have mentioned less than, so less than mu less than 75. Okay, your claim, this should be your claim. Significant level, they have mentioned alpha 0.05. Then calculate your c value, x bar. You know this x bar. Number of observations is 15. Sigma they have given at the end of the question. Calculate this c value. We denote it c naught. Here it is negative value, negative 0.87. We are using critical value approach. So you have to convert this alpha value to a critical value, which means c value. So since alpha 0.05 and this is a left tail test, get the value, get the critical value based on alpha 0.05. So you will be able to get that critical value negative 1.96. Value is negative 1.96. Okay, so what is your calculated value? Negative 0.86, negative 0.87. This is your calculated value, right? So you can calculate, you can compare this calculated value when critical value. So what happened? Your calculated value somewhere here, your critical value somewhere here. Okay, 0.05. Okay, this value should be negative 1.96. Okay, 1.96. Please make it correct. Okay. Anyway, since this is left tail test, you reject your H naught if your critical value greater than test statistic. But what happened here? Your critical value is, okay, they have mentioned 1.645. This should be 1.96. Okay, it doesn't matter, that value already less than 0.87. Okay, do you remember the values? Negative 1, negative 1.5. Values are what happened? Values are increasing, but the actual values are decreasing to left side. Okay, so your test statistic value is greater than your critical value. So do not reject H naught. Interpretation is what happened? Critical value less than your test statistic value. So 5% significant level, we do not reject the null hypothesis. Why? uh, because we do not have enough evidence to say that your from here to here, it is your claim. It is your claim. Mean daily charges charge for hotels and motels operating in South Carolina is less than $75. Okay, so this is the interpretation. Okay, let's do the same problem by using p-value approach. Calculate your sample mean. Step number one: mention what is the null hypothesis and alternative hypothesis. This is your claim. And identify what is the significant level alpha. Here it is 0.05. Compute the test statistic. Same as before, compute the test statistic. Okay. Next, since this is left tail test, what you have to do? You have previously calculated your z naught, then get the p value based on your c naught. Okay. Get your p value based on c naught value, your calculated value. How you get the p value? Go to the table, since this is left tail, go to the c table and find the area based on the c value. So that value is this. Since this is left tail, you can directly pick that value. Okay, so in this case your p value is 0.1922. Remember, do you remember this alpha value? It is 0.05. Okay, so you can compare. Your p value is greater than your alpha value, right? P value greater than your alpha value, so do not reject your null hypothesis. Same as before, you can interpret p value greater than significant level alpha. Therefore, 5% significant level. Okay, we do not reject the null hypothesis, and we do not have enough evidence to say that your claim. Okay, so this is the complete answer for interpretation, or let's say this is the complete answer from step 1 to step 4 and step 5. Step 5 is really important. Okay, conclusion of your work. Simply mention what happened, which one is greater than, or what happened, under what alpha level, why we do not have enough evidence to say that. Okay, we do not have enough evidence to say that your claim, because we do not reject your null hypothesis. We have our null hypothesis, so you cannot claim that your claim is going to be correct. Okay, okay. uh Last notes, you should remember this. You have to read the question very carefully, identify the key facts in the problem. Based on the alternative hypothesis, you have to identify what is this test, left tail, right tail, or two tail. Okay, based on your alternative hypothesis, find a solution for that particular problem using critical value approach or p-value approach. It is your choice, unless they haven't mentioned, unless they haven't mentioned in the problem. Okay, so these are the very basic and necessary steps when you are going to do a hypothesis test. So please go through the materials once again and make sure you have done everything up to date. Okay, okay guys, then I'll see you next time in another lesson. Okay, have a good day.